Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. Today we're going to be doing Unit 7, Lesson 7. Our main topic is properties of logs. So we're going to take the things that we learned about logs in our last lesson, and we're going to add to that knowledge with some properties that help us expand and condense logs and simplify expressions that contain logs. Don't forget to put your first and last name in the upper right-hand corner of your paper, the period and the date as well. All right, so our objective today is I will use the properties of logs to expand and condense log expressions. Mastery will be demonstrated by scoring at least 80% on the extra practice. So the very first property we're going to learn about is the product property. So the product property looks like this. The log base b of m times n is equal to the log base b of m plus the log base b of n. So notice that this is called the product property because m and n are being multiplied inside the same log. So if I take log base b and I have two things that are being multiplied inside that log, I can rewrite the expression with m and n in their own logs with the same base, and I can add the logs. So here's another example of what that could look like. Let's say that we have the log base 2 of x times y, or xy, and that would be equal to the log base 2 of x and the log base 2 of y added together. So the log base 2 of x plus the log base 2 of y. So notice that x and y were being multiplied in the same log. They each got their own logs with a plus sign in between, and the base 2 is the base of both of those logs. All right, let's talk about the quotient property. So because we're talking about a quotient, that means we're talking about division. And notice that this time m and n are being divided in the same log. So the log base b of m divided by n, so when you see division in a log, you use this property, the quotient property. Then you can give m and n their own logs. Notice that the base is still base b, but this time you subtract. So because m was in the numerator, it's in the first log, it's being subtracted by n, the log base b of n was in the numerator, it's in this, or the denominator, sorry, it's in the second log. So another example of this could look like the log base b, sorry, the log base 3 of, let's say, x divided by 2 would then be equal to the log base 3 of x minus the log base 3 of 2. So notice that x was being divided by 2. X is in the first log, 2 is in the second log. I'm subtracting both of them, and this time my base was 3. All right, let's talk about the power property. The power property is going to come in handy a whole lot in Algebra 2. So the power property, it's called the power property because we're dealing with an exponent. We're dealing with a power, m to the n. So when you have log base b of m to the n, you can take that exponent and move it to the front of the log and rewrite it as n times the log base b of m. So what's really handy about that is when you have an exponent inside a log, so log, let's say the log of x squared. This property lets us take that exponent, move it out in front of the log, and then multiply it by the log. So the exponent becomes like multiplication, and you multiply it times the log itself. And normally I would have you guys do a lesson where we prove that these properties exist. So we know that they're not just random made up rules, but we don't have time for that lesson this year, unfortunately. So we're going to take these properties, and we're going to use them to help us expand and condense logs. So in example 1 here, we have the log base 4 of 32 plus the log base 4 of 2. What we have is two logs that have the exact same base, and they're being added together. Which property had logs with the same base being added together? The product property had logs with the same base being added together. So what this says is then we're going to use that product property. We're going to combine these guys into one log, the log base 4 of, and we're going to multiply 32 by 2. So 32 times 2. So the log base 4 of 32 times 2. So the log base 4 of 64. Now, because we're dealing with log base 4, and I see that 64 can be rewritten as a power of 4, I'm going to rewrite this as the log base 4 of 4 to the, let's see, 4 times 4 is 16. 16 times 4 is 64. So 64 is the same thing as 4 to the third power. So that means I have log base 4 of 4 to the third power. Now, using the power property, where we take the exponent that's inside the log and we bring it out in front using multiplication and change it to multiplication, I'm going to take this 3 from my exponent and I'm going to move it to the front of the log. So I'm going to have 3 times the log base 4 of 4. So I know I'm throwing a lot of new information at you right now, but there's something else that we can actually do with this. So whenever you have the log base 4 of 4, so if you have the log where the base and what's in the log match, that actually simplifies to 1. So instead of having 3 times the log base 4 of 4, we really have 3 times 1, which is simply 3. So that whole expression, the log base 4 of 32 plus the log base 4 of 2, simplifies to 3. I know that was a lot. All right, so now I want you to try part B on your own. So you have 6 times the log base 2 of x plus 5 times the log base 2 of y. The first thing you need to do is you need to bring that 6 that's being multiplied by the log back in as an exponent, and the same thing with the 5. I'll show you what that looks like for the first one, and then I want you to finish the problem on your own. So this would become the log base 2 of x to the 6th plus log base 2 of y to the, and then you're going to use the product property again and combine these into one log. So go ahead and give this a shot. What do you get when you simplify this into one log? All right, so you should have brought that 5 to be the exponent of y, so log base 2 of y to the 5th. Then we combine those into one log, since we have 2 separate logs with the same base that are being added together. So we keep it log base 2 of x to the 6th times y to the 5th, and there's something to simplify further. All right, let's do part C. So part C, we have the log base 3 of 5x minus the log base 3 of 3x. So the first thing that we're going to do is we are going to, let's see, I have 2 logs. They have the same base. They're being subtracted. So this is the quotient property. So when I combine them into one log, I'm going to be dividing. We have that m over n. So we're going to have the log base 3 of 5x divided by 3x, and x divided by x is 1. So this is simply the log base 3 of 5 thirds. And that's it. All right, now why don't you give this one a shot? So 2 times the log base 4 of 6 minus the log base 4 of 9. Before you can combine these into one log, make sure you bring that 2 back in as an exponent of the 6. Go ahead and finish this problem on your own. All right, so you should have rewritten this as the log base 4 of 6 squared minus the log base 4 of 9. Combining those into one log, we're going to take 6 squared and divide it by 9. Well, 6 squared is 36, so the log base 4 of 36 over 9. 36 divided by 9 is 4. So now we have the log base 4 of 4. Well, if the base and what's in the log match, what do we have? We have 1. So that actually simplifies to 1. All right. So now let's do some more complicated ones. So we have the log of 5 plus the log of 6 plus 2 times the log of 11. So we have the log of 5 plus the log of 6 plus, I'm going to bring that 2 that's out in front and make it an exponent of the 11. So I get the log of 11 squared. All right, I swear those bells get longer every time. So we are adding a bunch of logs. We're adding all 3 of these logs. They all have the same base. Remember, when you can't see the base, you have base 10. So these are all log base 10. So we have the log of 5 times 6 times 11 squared. So we're going to go ahead and multiply that out. We're going to have 5 times 6 times 11 squared is 121. We get 3,630. So our final answer is the log of 3,630. All right, letter F. 3 times the log of 3 minus 12 times the log of 3. So go ahead and simplify this all on your own. So the first thing I did was I brought this 3 in as an exponent of the 3. I brought this 12 in as an exponent of the 3 as well. So I have the log base 3 to the third. Sorry, why did I keep saying log base 3? The log of 3 to the third minus the log of 3 to the 12. So I combine those into one log where I divide 3 cubed over 312, 3 to the 12. I don't know why I can't read this problem. Bear with me. So then I have the log of, so I know that when I have bases that are the same of my powers, I can subtract the exponents. So I have 3 to the 3 minus 12, which is 3 to the negative 9th. To make that exponent positive, I just put it over 1 and then moved it to the denominator. So I have the log of 1 over 3 to the 9th. 3 to the 9th is 19,683. So my final answer is the log of 1 over 19,683. All right, moving on. So now we're going to expand the expression with as many logs as possible. So I have the log of 4x over y, and I want to write this out in as many logs as possible. So I want each of these things to end up in its own log. 4 will have its own log, x will have its own log, and so will y. So this expression is going to end up needing 3 logs. So I know that when I see division in my log, I'm going to use the quotient property first. So I'm going to have the log of 4x minus the log of y. Then I notice that inside this log here, I'm multiplying 4 by x. So here I'm going to use the product property. So I'm going to have the log of 4 plus the log of x minus the log of y. And there we go. We've expanded that expression as far as it can possibly go. All right, part B, go ahead and give this problem a shot on your own. You're going to end up with needing to use 2 logs, and you're going to end up needing to use the power property. And you're going to want to see if 729 can be rewritten as a power of 9. Go ahead and give that a shot. So I'm going to walk us through most of this problem. So I rewrote it as the log base 9 of x to the 4th minus the log base 9 of 729. We're going to take this 4 and we're going to bring it out in front of the log using the power property. So 4 times the log base 9 of x minus, and then I realized that 729 is 9 to the 3rd power. Well, using the power property one more time, I'm going to bring that 3 out in front here. I'm going to have 4 times the log base 9 of x minus 3 times the log base 9 of 9. And what is the log base 9 of 9? It's 1. So this is really 3 times 1, which is just 3. So 4 times the log base 9 of x minus 3 would be our final answer. I don't know why I wrote a 3 there, just kidding. There we go. Let's keep moving on. All right, go ahead and try part C on your own. All right, so I bet you got the log base 3 of 250 minus the log base 3 of 37. Well, I would accept this answer as your final answer. I have no problem with this answer. But if you are feeling kind of fancy, you could see 250 as 25 times 10, and nothing goes into 37 because it's prime. So I could rewrite the log base 3 of 25 times 10 as the log base 3 of 25 plus the log base 3 of 10 minus the log base 3 of 37. And then I realized that 25 is really a power. It's 5 squared. I mean, this is just if we're feeling really fancy and really wanted to write this in as many logs as possible. I can bring that 2 out in front of this log. So I have 2 times the log base 3 of 5 plus the log base 3 of 10 minus the log base 3 of 37. So I would accept that as your final answer, or I would accept this as your final answer. Isn't that kind of cool? I don't know. All right, now let's do part D. Go ahead and do part D on your own. I'll see you on the other side. I ended up with 2 plus 5 times the log base 3 of x. And part E, so we have the log base 3 of 3 times uv cubed, and then that is being squared. So there's a couple ways we can go about this. First, since the log base 3 of 3 is being multiplied by uv cubed squared, we can go ahead and write that as the log base 3 of 3 plus the log base 3 of uv cubed squared. And then the log base 3 of 3 is 1. We can bring this 2 out in front, and we're going to have 2 times the log base 3 of uv cubed. And then because uv cubed is being multiplied, we can split that into 2 separate logs. So we would have 1 plus 2 times the log base 3 of u plus, now be careful because this 2 is being multiplied by this whole thing. So we also need to multiply 2 log base 3 of u, just kidding, of v cubed. We have to multiply that by 2 as well. So then we still have this exponent here that can be brought out in front, and we're also multiplying it by the log. So we're going to have 1 plus 2 times the log base 3 of u, I almost thought that was a 4, of u plus 6 times the log base 3 of v. And that would be our final answer. Now, the other way we could have gone about this is we could have gone ahead and taken uv cubed squared. So I'm going to do it that way real quick too, just off to the side here. Ignore this for just a second. We're going to come back to it. But we would have the log base 3 of 3, and then we would have u squared v to the 6th. And then we could go ahead and write this out as log base 3 of 3 plus the log base 3 of u squared plus the log base 3 of v to the 6th. And we'd end up with 1 plus 2 times the log base 3 of u plus 6 times the log base 3 of v, which is the exact same answer we had doing it the other way. So it doesn't really matter like what order those steps are in. You can do this either way is fine, whatever way made more sense to you works for me. All right, then go ahead and do the log of 100x squared divided by y. So I bet you got at least to this step. The log of 100 plus the log of x squared minus 6 times the log of y. But we need to keep going from there because 100 is the same thing as 10 squared. So this is the log of 10 squared plus the log 2 times the log of x minus 6 times the log of y. We can use that power property and bring that 2 out in front of this log. From there, we can use the power property again and bring the 2 out in front of this log. So 2 times the log of 10 plus 2 times the log of x minus 6 times the log of y. Then what base are all these logs? If the base isn't given, the base is 10. It's the common log. So the log base 10 of 10 is 1. 2 times 1 is 2 times 1 is 2. So 2 plus 2 times the log of x minus 6 times the log of y. And I believe that's all for our notes today. So go ahead and do your extra practice, and I'll see you back in class. Have a good day.